हरि करना।
So before we have seen machine learning classification of algorithms based on types of learning. Now it's time to see the deep learning classification based on types of learning. So as we have discussed earlier, ML algorithms are typically used to solve problems that involve structured data such as tabular data or time series data, and they rely on hand engineered features to learn from the data. So ML algorithms include linear regression, logistic regression, decision trees, random forests, supervector machines, and naive Bayes classifiers. In contrast, deep learning algorithms are designed to work with unstructured data such as images, audio, or text, and they learn to extract features from the data automatically. So deep learning algorithms are typically based on artificial neural networks which are composed of multiple layers of interconnected nodes that process the data in a hierarchical manner. So deep learning algorithms, there is a clear cut distinction between a deep learning algorithm and machine learning algorithm other than the type of data. Of course, even a machine learning algorithms also, we can use a machine learning algorithms type of machine learning to work on image data or text data. So that's not the main distinction. The main distinction between a machine learning and deep learning is, first thing, the way it learns. That's the simple way of learning, based on the rule based. You will have some mathematical equation. Based on that mathematical equation it learns. But when it comes to deep learning, the deep learning, and one more important, there you have to do the feature engineering. You have to give the features, the best features, then the algorithm will take up the features and then it will learn on its own. Depends on type of algorithm. Okay, but here in deep learning, so the feature engineering will done by the algorithm itself. And what type of learning it uses neural networks. There is a fundamental distinction of how the algorithm works itself. There it's a simple mathematical equation, and the feature engineering has to be done by you when it comes to the machine learning. But whereas here, the algorithm, they learn, basically are deep learning algorithms, they learn to extract features from the data automatically. They learn to extract features from the data automatically, which is part of neural networks. It's a part of neural network itself. So deep learning algorithms automatically learn to extract feature from the data automatically, and so they use a neuron system to process the whole learning. So that's the main and the fundamental distinction between the deep learning and machine learning. Not the data. So data could be somehow can be handled, until unless if it is complex data, if it is too huge data and complex data, then a machine learning algorithm may not handle. But if it is no, even the image and then text data can also be handled by the machine learning algorithms. That's not the main important aspect of distinction. The main thing is how it learns. And second one is, there you have to do the manual feature engineering. Here the algorithm, it's a part of neural network. I hope the difference is clear. The difference between machine learning and deep learning is clear. So now let's see the only deep learning algorithms here. How can we classify deep learning algorithms? As we have supervised unsupervised reinforcement and ensemblement algorithms there in machine learning. Similarly, we'll have here also, because at the end of the day, the distinction is only the way, how it learns, how it works. That is the only difference there and here. There, it depends on a rule, but here it depends on the multiple hidden layers. It depends upon the multiple layers. Each consists of a neuron or perceptron, and then it consists of a cost function and also many other important aspects of a neural network. So that's, the system itself is different, but the activities can be done similar to that. The learning type, here also we can have a supervised learning type, where we will label it, and we will label the data before only. For the deep learning also we can have unsupervised learning type, and similarly reinforcement. So that's the reason. So the distinction is pretty straightforward. The distinction is only how, or the distinction is the architecture of the system, architecture of the machine learning or the deep learning. The architecture is different, that's it. Rest all remains same. So supervised learning, again it will be classified further down into regression and classification. So regression, here we have a feed forward neural network, FNN. And one more thing I just want to tell you before we look into the various algorithm types. So again, the same algorithm can be used for the regression as well as classification. So regression, feed forward neural network, then convolutional neural network. But before that, do you want to understand what is regression with respect to the deep learning? So it's same. So supervised, first let's understand supervised learning. Supervised learning, supervised learning is a type of learning. It's a type of learning where the algorithm learns from labeled data to predict the output for new inputs. So it learns from labeled data to predict the output for new inputs. In deep learning, the most common supervised learning tasks are regression, classification, and time series prediction. So now first let's see regression. So what is regression? So in regression, the algorithm learns to predict a continuous value output. This is very, very important. See, I don't want to explain these regression, supervised, unsupervised multiple times. That's the reason I did not explain this in machine learning video. So here I'm explaining, by and large they are same. Only the architecture differs between ML and DL. Other than that, the concept remains same. So that's the reason I did not explain. So regression is mainly used. Regression, the algorithm learns to predict a continuous value. Your target variable would be continuous value output, or your outcome or output would be continuous value. So examples of regression tasks in deep learning include predicting predicting the price of a house, predicting the price of a house based on its features, or predicting the stock price of a company. So now let's see various algorithms which comes under regression, or various algorithms which we can use to calculate, to predict a continuous value output. Okay, FNN, that's a feed forward neural networks, convolutional neural network, CNN, then recurrent neural networks, RNN, then long short term memory, LSTM, and gated recurrent units, GRU, then auto encoder, AE, and variational autoencoder VAE. So I can explain each and every algorithm in one or two paragraph, but the video will become too large. Here, the point of no the main point, the agenda of this video is to convey the proper categorization of machine learning and deep learning, because there is nowhere given with this much of clarity. I have done a huge amount of research and then I have put it in a video so that you will never have a confusion between ML and DL. So then we have denoising autoencoder and convolutional autoencoder. So then we have classification. So we have seen the regression algorithms. Now let's understand what is classification and let's see various algorithms from classification. So in classification, the algorithm learns to predict a discrete class label output. That's the main difference. Two important things to be remembered. One is your output is discrete and discrete class, discrete categories, and second one is it's a labeled. You know what is that label before only. Which label it's going to, the output labels were designed or defined, predefined only. Okay, so classification, the algorithm learns to predict a discrete class label output. Examples of classification tasks in deep learning include image classification. Example, identifying if an image contains a cat or a dog. And sentiment analysis. Example, identifying if a movie review is positive or a negative. So now let's look into the various algorithms who comes under classification. Again, FNN, this can also be used for the categorical outcome variable with the labeled one. Then convolutional neural network, recurrent neural network, then long short-term memory LSTM, gated recurrent units. In addition to the common algorithms between regression and classification, we can use capsule networks, deep belief networks DBN, deep convolutional neural networks, deep convolutional neural networks called DCNN. These are called deep convolutional neural networks. This is only used for the classification. So if the outcome, if your outcome variable is categorical, then we will use a deep convolutional neural network. Then deep residual networks or ResNet. Then inception networks, exception networks, and many more. It goes on. Then we have a time series prediction. What is a time series prediction? In time series prediction, the algorithm learns to predict future values in a sequence of data points. So in a time series prediction, the algorithm learns to predict future values in a sequence of data points. Obviously, these are also labeled. So examples of time series prediction tasks in deep learning includes predicting the future stock prices of predicting the future stock prices, or forecasting the weather patterns. Again, it depends upon it. It will become a deep learning. The same tasks you can do with the machine learning also, but there, how do you do? The architecture is different. Here the architecture is different. Here the whole neural network comes into the picture. It's very complicated. Neural network will handle the problem. That's the reason here you'll get the best results than compared to the machine learning. Of course, for some issues, for some problem statements, for some use cases, neural networks would be the overkill. In that case, machine learning is the best fit. So time series prediction. In time series prediction, the algorithm learns to predict future values in a sequence of data points. So examples of time series prediction are either stock price prediction or weather forecasting. So now let's see examples. Again, a recurrent neural network is widely used. The same recurrent neural network is used. Of course, if it a time series data, let's take your speech or any data from Internet of Things, IoT, or uh, even your chat GPT or any other Siri or Alexa. These are all time series data. These are all time series data. Even your vehicle maintenance data, your values data from your car sensors, and production data, predictive maintenance data. So these are all time series data. So recurrent neural network is widely used for the time series data heavily. This is the most important algorithm for time series data. Of course, the same algorithm can be used for the regression and also for the classification. Okay. And long short term memory LSTM, gated recurrent units GRU, encoder decoder networks EDN, autoregressive neural networks. You have seen autoregressive algorithm in machine learning, but here this is called autoregressive neural network, AR, autoregressive neural network. And moving average neural networks, again this is again moving average you have seen in machine learning also, but this is moving average neural network. The architecture is completely different. There it's a simple mathematical equation, but here you will use a neural network architecture. And auto-regressive integrated moving average, ARIMA. There also we did ARIMA with a simple equation. That's why it's a machine learning algorithm. But when it comes to the ARIMA neural networks, here you will use the whole ecosystem of neural networks. And seasonal autoregressive integrated moving average neural networks, SARIMA neural networks. And WaveNet, and that's it. So this is how you categorize your supervised learning type deep learning algorithms into regression, classification, time series prediction. Of course, many of the algorithms would be common in all three types. However, there are new algorithms or also in the respective types. Then from supervised, we will move on to the unsupervised learning type. Unsupervised learning type is a type of learning where the algorithm learns from unlabeled data to discover hidden patterns or structures in deep learning. The most common unsupervised learning tasks are clustering. We will see what it is, and then we'll also have dimensionality reduction, association rule learning, anomaly detection, and generative models. But before we get into that, I just want to make sure you understood about the unsupervised learning. Unsupervised learning is a type of learning where the algorithm learns from unlabeled data to discover hidden patterns or structures. Okay. So first let's see clustering. Let's see clustering first. In clustering, the algorithm learns to group similar data points together. So there won't be any outcome or output labeling. There won't be no labeling for the output variable. You'll just take up your data, and then after taking up your data, you'll cluster the data based on the patterns, hidden patterns inside the data. So that's your cluster. So in clustering, the algorithm learns to group similar data points together. Examples of clustering Examples of clustering tasks in deep learning includes grouping similar customer behavior or grouping similar image features. Very important in uh, DL, deep learning, grouping similar image features. Image features. Then let's see some of the clustering algorithms. Self-organizing maps, SOM, deep embedded clustering, deep embedded clustering, DEC, and variational autoencoder, VAE. Of course, the same thing we have used VAE for regression also. Then we have generative adversarial networks, GAN. GAN is specifically for unsupervised learning, that to clustering, okay. So CNN and RNN can be used in regression and classification and time series prediction, but for clustering, for unsupervised learning, GAN is the famous one, most famous one. Generative adversarial network, generative adversarial networks, GAN. Then let's get into the dimensionality reduction now. What is a dimensionality reduction? So in dimensionality reduction, the algorithm learns to reduce the number of input features while retaining the most relevant information. Example of a dimensionality reduction task in deep learning include image compression or speech recognition. Image compression or speech recognition. I'm going to repeat what is a dimensionality reduction one more time. In dimensionality reduction, the algorithm learns to reduce the number of input features. Dimensionality reduction, reducing the dimensionality, reducing the dimensions. So that's what happens. So dimensionality reduction, the algorithm learns to reduce the dimensionality or basically number of input features. It will reduce the number of input features while retaining the most relevant information. So now let's see some of the algorithms from dimensionality reduction. Autoencoder, you have seen autoencoder, even regression and regression also. So it can be used as a dimensionality reduction algorithm with slightly modified techniques. Then variational autoencoder, VAE. So VAE can be used as a clustering algorithm, then regression algorithm, then also in other places. Then principal component analysis, PCA, T distributed stochastic neighbor embedding, TSNE. So these topics, dimensionality reduction, we have discussed in detail in other course. You can watch there. That's a intuitive sampling and distribution course. Then we have the third type, association rule learning. Association rule learning. So in association rule learning, the algorithm learns to identify patterns or relationships between variables in the data. So examples of association rule learning tasks in deep learning include market basket analysis or a recommendation system. Recommendation system is the best example. So association rule learning is the algorithm learns to identify patterns or relationships between the variables in the data. So what association rule learning is going to do is it's going to identify the patterns or the relationships between the variables. Now some of the algorithms for this, deep a priori, same algorithm that we have used for the machine learning with the different architecture. Then sequence mining, very important, sequence mining. Then we have anomaly detection. Anomaly detection. So, in anomaly detection, the algorithm learns to identify rare or unusual events in the data. That's what we call as a anomaly, or detecting anomalies or outliers. Examples of anomaly detection tasks in deep learning includes fraud detection or network intrusion detection. Fraud detection is widely used application by various companies. So, and network intrusion detection also. So in simple way, uh, anomaly detection is an algorithm learns to, because it's unsupervised learning na, it learns to identify rare or unusual events in the data. Rare or unusual events in the data. Example of this anomaly detection is fraud detection. And one algorithm, autoencoder algorithm, which comes under anomaly detection. Then variational autoencoder VAE. So basically, VAE can be used as a clustering algorithm, dimensionality algorithm, and even anomaly detection algorithm. And generative adversarial networks GAN, and one class SVM. After anomaly detection, so what we have here is generative models. Generative models, the algorithm learns to generate new data that is similar to the input data. So examples of generative models in deep learning include image image synthesis or music generation. Image synthesis or music generation. So the algorithm learns to generate new data that is similar to the input data. So some of the algorithms who does this kind of work in deep learning is variational autoencoder and generative adversarial network GAN, and autoencoder generative model, autoencoder generative model, then denoising autoencoder. So these are the generative models. Then what's next? It's a reinforcement learning. So reinforcement learning is a type of learning where the algorithm learns to make decisions by interacting with an environment and receiving rewards or punishments for its action. The most important first one, it's going to interact with the environment. It learns to make decision. It learns to make that algorithm learns to make decisions by interacting with an environment and receiving rewards or punishments for its actions. So in deep learning, the most common reinforcement learning tasks are value based methods, policy based methods, and model based methods. So first let's begin with value based methods. So, in value based methods, the algorithm learns to estimate the value of each possible action in a given state. Value of each possible action in a given state. Examples of value based methods include methods in deep learning include Q learning or deep Q networks, DQNs. So these are the algorithm deep Q networks, or we call it as a DQN, and double DQN, and dueling DQN, and asynchronous advantage actor critic, or you can call it as A3C. A3C. So basically, it's a value based. So the algorithm learns to estimate the value of each possible action. So it will measure the value of each possible action in a given state. It's value based. And deep deterministic policy gradient, DDPG. Then twin delayed DDPG, that's a TD3. So then we have policy based methods. So policy based methods in policy based methods, the algorithm learns to directly optimize the policy or strategy that maximize the cumulative reward. So the algorithm learns to directly optimize the policy or strategy that maximize the cumulative reward. So whichever policy or whichever strategy gives the highest cumulative reward, whichever gives the maximum cumulative reward, and that policy or that strategy will be optimized, and that one will be used continuously. So that's what is called policy based methods. So examples of policy based methods in deep learning include policy gradient methods or actor critic methods. And here you can see policy gradient or proximal policy optimization, PPO, and trust region policy optimization, TRPO. Then asynchronous advantage actor critic, that's A3C. Then deep deterministic policy gradient, DDPG, and twin delayed DDPG, that's a TD3. Then the next type we have here is reinforcement learning, that is model based methods. model Model based methods. So in model based methods, the algorithm learns a model of the environment and uses it to make decisions. So in this model based methods, the algorithm learns a model of the environment. It will understand the model of the environment and uses it to make decisions. So the examples of model based methods in deep learning include model based reinforcement learning or planning algorithms. So from this is where the planning algorithms comes into the picture. So model based reinforcement learning and then planning algorithms. So with this, we have completed all three types of learnings, that is supervised, unsupervised, reinforcement, and you can see the each algorithm under the respective learning type, and each learning type is further categorized into various categories. For example, if it is a supervised learning, regression, classification, time series. If it is unsupervised, clustering, dimensionality reduction, association, rule learning, anomaly detection, generative models. If it is reinforcement learning, value based methods, policy based methods, model based methods. And what's left? Ensemble methods. That's what is left now. Ensemble methods. So ensemble methods in deep learning involve combining multiple individual deep learning models to improve the accuracy of predictions. So examples of ensemble methods in deep learning include, again, bagging, boosting, etc. So ensemble methods can be used with various types of deep learning models such as convolutional neural networks, recurrent neural networks, RNNs, and generative adversarial networks, GANs. So ensemble methods have been shown to improve the accuracy of deep learning models and reduce the overfitting. And here are some of the ensemble methods for deep learning: stacking, deep ensembles, boosting. In boosting, we can have AdaBoost, gradient boosting, or XGBoost for the boosting. And bagging, obviously bagging, uh, it's a bootstrap, yes, bagging, bootstrap aggregation, and then random forest. So these are the examples of algorithms from ensemble methods. Basically, these ensemble methods can be used with various types of deep learning models such as convolutional neural networks, CNN, recurrent neural networks, RNNs, and generative adversarial networks, GANs. And ensemble methods have been shown to improve the accuracy of deep learning models and reduce the overfitting. And this is the deep learning categorization or classification based on types of learning